This is pre-algebra lesson 8-7, solving systems of linear equations. A system of linear equations is two or more linear equations, two or more lines. The solution to a system of linear equations is any ordered pair that is a solution to both equations simultaneously. To see if a particular point is a solution, we must substitute the point in both equations, and it must make both equations true. If it makes one equation true and one equation non-true, then it's not a system of equations. It's not a solution to the system. For example, if I asked you to tell whether the ordered pair is a solution to the system of equations, and I gave you an ordered pair, you're just going to plug in that ordered pair for each system to see if it makes a true statement. For example here, I want to know, is 0, -2 a solution to 3x minus 2y equals 4 and 2x minus y equals -2? So what I like to do is I like to number my equations. This is equation 1 and this is equation 2. It makes it much easier to be able to figure them out later. Remember, this is your x value and this is your y value. So what I'm going to do is in equation 1, I'm going to substitute in 0 for x and -2 for y. So I have 3 times 0 minus 2 times -2. Does that equal 4? That's what I'm trying to figure out. 3 times 0 is 0. -2 times -2 is positive 4. Does that equal 4? Yes, it does. It checks in that equation. Now let's see if it checks in the second equation. Same thing. We're going to plug in 0 for x and -2 for y. So we have -2 times 0 minus -2. Make sure you have a minus -2. Does that equal -2? So I have 0 minus minus is a plus. That does not equal -2. So no, this is not a system. This is not a solution to the system of equations because it solves the first equation, but does not solve the second equation. Okay? So if it solves one but not the other, it's not a solution to the system. It has to solve both of them in order to work for the system. Let's look at problem number 2. I still have two equations, equation 1 and equation 2. So in equation 1, I have y, which is 2, equals -5 times x, which is 4, plus 22. So does that equal, okay, let's find out. -5 times 4 is -20, plus 22, okay. -20 plus 2 does equal 2, so it checks in the first equation. Let's see if it checks in the second equation. Give myself a little bit more space here. In the second equation, I have y, which is 2. Does that equal 8 times 4 minus 30? So 2, does that equal 32 minus 30? Yes, it does. 32 minus 30 is 2. So 2 equals 2, so that checks. So yes, 4-2 is a solution to this system of equations because it solves both equations simultaneously at the same time. Let's look at this last one here. I'm going to change colors just for the fun of it. That's equation 1. This is equation 2. Equation 1 says x, which is -24, minus 4 times y, which is -10. Does that equal 16? So -24 minus minus is a plus, plus 40. Does that equal 16? Well, last time I checked, 40 minus 24, okay, is 16. So 16 equals 16. It checks in that equation. Problem number 2, equation number 2, -2 times x, which is -24, plus 6 times y, which is -10. Does that equal -12? Well, that'd be positive 48 minus 60. Does that equal -12? -12 does indeed equal -12, so it checks there, so yes. -24, -10 is a solution to this system of equations. So that's one way to find out if a number is if you want to find out if a coordinate pair is a solution to your system, you just plug it in to see if it solves the system of equations. If it does, then it is. If it doesn't, then it doesn't. The second way to do it is to graph. Okay? One way to solve a system of linear equations is to graph each equation on the same coordinate plane and find the point or points of intersection. So we're going to solve y equals -3x plus 2 and y equals x minus 2 by graphing. So the first thing we're going to do is graph each line. These are nicely written in slope-intercept form. So I'm going to number my equations. This is equation 1, and this is equation 2. In equation 1, my slope is -3, and my y-intercept is 2. In equation 2, my slope, there's no number in front of x, which means the slope is 1, because remember, if there's no number in front of a variable, it is always an assumed 1. My y-intercept is -2. Make sure you remember sign goes with number. So I'm going to graph both of those equations. I'm going to graph the first equation, y equals -3x plus 2. So the first thing I'm going to do is I'm going to graph where it crosses the y-axis, which is at 2. And my slope is down 3, right 1. 1, 2, 3, right 1. 1, 2, 3, right 1. So there's the graph of my first equation. I'm going to graph that. I think I'll even graph it in purple or purplish. I missed. I'm straighten my line up here a little bit. It's really important to use. It is very, very important to use a ruler here because you need your lines to be dead on or they may not cross in the right place. So there's my graph of this equation. I'm going to label it, and because I labeled these 1 and 2, I can label this 1 and 2, which makes it so much easier. I can find my equation very quickly. In equation 2, I'm going to do equation 2 in green just because I can. In equation 2, my y-intercept is at -2, so I'm going to plot -2. My slope is 1, so it's up 1 over 1, up 1 over 1, up 1 over 1. I'm going to graph this line. Again, I'm going to graph it in color that I actually. Okay, so there it is, graph in green. Oh, I got that one pretty good. I'm going to put my arrowheads on it as well. And I'm going to label it. This is equation 2. And as you can clearly see, these two equations cross each other at a coordinate point. I'm going to circle that coordinate point in red so you can see it. They cross at 1, -1. That is the solution to this particular system of equations. So I would write 1, -1, put it in a coordinate pair, and box it because that's the solution to the equation. We graphed each line, we found where they intersected, and we named that intersection. You must name this intersection. If you do not name the intersection, you haven't solved the equation. Okay? It may visually look like you have, but until you name it, you haven't solved it. So as you can clearly see, once you understand how to graph and slope-intercept them, it's much faster to be able to graph. Let's look at a couple more examples. Not always will they be written in slope-intercept form. As you can clearly see here in problem number 5, they're not written in slope-intercept form, so we have to rewrite them. I am going to rewrite each equation in slope-intercept form. Equation 1, I would have y equals, I have to add my x. Y is going to equal x plus 4. And I keep them in y equals mx plus b form. It's best to keep them in slope-intercept form because it's the easiest way to be able to write your equations. Okay, so in equation 1, my slope is 1 and my y-intercept is 4. So I'm going to graph that. I cross the y-axis at 4, which is right there. My slope is up 1 over 1. Okay? You might look at that and say, but you only have 2 points. 2 points will make a line. Do realize up and to the right is the same as down and to the left, so here's another point if I wanted to put it on the graph. Okay, so I'm going to graph this. I'm using black values because it's just easy. There's my graph. Notice how you extend it beyond the points you actually plotted because you don't know where it's going to cross. So that would be a good idea to make sure that you do that. Okay. Label my x on my axis. I forgot to do that on the last graph. So there's my first equation, so I'm going to label that equation 1. Okay. My second equation, I have to subtract my 2x. So I will have y equals -2x minus 8. So my slope is -2, my y-intercept is -8. You're like, well, -8 doesn't fit on this graph. You're right, it doesn't. Okay, and I don't really want to try to guess where -8 is because I might guess wrong. So I'm just going to pick some points. Okay, what happens if x is 2? Or let's do -2. Okay, I'm just going to make a little table of values. That can happen sometimes. I'm going to put a little table of values here because I don't have, if I had my own graph, I'd just extend it so that it went out to 8. But since I don't have a piece of graph paper here that goes down as far as 8, I'm going to show you what you can do. I'm going to pick a point. I'm going to say that x equals -2. When x equals -2, I have -2 times -2, which is +4, minus 8. Okay, +4 minus 8 is -4. So there's a point I can graph right there, -2, -4. I'm going to graph that point, -2, -4 is here. Now I can use my slope, which is down to right 1, or up to left 1. Up to left 1. Okay, and now I can plot this graph. I'm a little off. Stretch my graph up a little bit here. There we go. And my little arrowheads on my graph. My equation is equation number 2. And you can see that they intersected at this point right here, which happens to be -4, 0. So my solution of my equation is -4, 0. And I can always check that by putting it back into the original equation and seeing if it makes a true statement. If I put in -4, 0 in equation 1, I have y equals -4 plus 4. So 0 equals 0. Yep, that works. It works in equation 1. In equation 2, it says y, which is 0, equals -2 times -4, which is +8, minus 8 is 0. Yes, it does work in both of them, so that is the solution to the equation. Let's look at problem number 6 here. I don't know why. Yeah, I didn't think to number 6. 4x plus 2y equals 8. So I need to solve that for y. So equation 1, I'm going to subtract 4x. So I have 2y equals -4x plus 8. But I need to solve this for y, not 2y, so I'm going to divide everything by 2. So I have y equals -2x plus 4. So there's my first equation. I'm going to go over that again, equation number 1. My slope is -2. My y-intercept is 4. So I'm going to go up 4. I'm going to graph that. And my slope is down to right 1. Down to right 1. So there's my points. I'm going to graph those. Nice and neat and tidy. There we go. Make sure you always use a straight edge so that it ends up to be where you want it to be. This is equation number 1 for me. Equation number 2, I'm going to subtract 2x. So equation number 2 then, which I'm going to put right here, I have y equals -2x plus 5. So my slope is -2 and my y-intercept is 5. So I cross the y-axis at 5. My slope is down to right 1, down to right 1, down to right 1. And I'm going to graph this equation. And you might say, well, this is Sheila, and I'm not seeing how these are going to ever cross. Okay? It's because they won't ever cross. Look carefully at these two equations, you'll notice something very interesting. They both have the same slope, don't they? Since they both have the same slope, they're never going to cross, okay? Because they just won't cross. If we get two lines that have the same slope, much like these two lines do, what you do is you recognize that they'll never, ever, ever cross, which means if they don't ever cross, there's no solutions. These lines are parallel, okay? Parallel lines. So your solution is to say there is no solution. If your lines don't cross, there is no solution. So the solution is no solution because they're not going to cross. That's a perfectly viable solution. Okay? Let's take a look at some other examples. How about y equals x minus 6 and x minus y equals 6? First equation's already written in y equals form. My slope is 1, and y-intercept is -6. Again, you're like, oh, this is she line to put the slope, put the y-intercept. Well, this one I can actually do pretty well. There's -6. Up 1 over 1, up 1 over 1, up 1 over 1. And I can graph that point pretty easily. Or that line, I should say. Okay, so there's that line. I'll put a little arrowhead on it. Call it equation 1. Let's look at the second equation. equation 2, I'm going to have to subtract my x. So equation 2, I have negative y equals negative x plus 6. I don't need a negative y, so I have to run a negative through everything. So equation 2 is actually y equals x minus 6. Wait a second. That's the same equation as this guy. Which means my two lines land right on top of each other. So I can just rewrite this as number 2. Which means, since the second line lands right on top of the first line, the solution of this equation is infinitely many solutions. Any solution that lies on this line right here, so I'm going to be drawing a straight line, is a solution to both equations simultaneously. So the answer to this one is infinitely many solutions on the line, and yes, you have to say the line, and you have to name the line, y equals x minus 6. Because the only solutions are the solutions that land on that line. Anything that does not land on that line is not a solution to the equation. These are what we call simultaneous lines. They land on top of each other, they coincide. They do one on top of the other. Okay, so remember, there's only 3 possibilities you can get when you graph an equation. 2 equations that have the same slope but different y-intercepts, okay, will have no solution. They'll be parallel. Same slope, different y-intercepts, lines will be parallel. 2 equations that have different slopes will have one solution. 2 equations that have the same slope and the same y-intercept will have infinitely many solutions. You'll only get one of 3 solutions with linear equations. They'll either cross in one spot, they will never cross because they're parallel, or they will land right on top of each other. And that's solving systems of equations.